Jolie, Assistant Professor in LJ Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject microwave engineering. So, we are going to learn about the microwaves. Now you know about what are the microwaves which we studied earlier. So now from this video you will learn about the various microwave active and passive devices. So very first we are going to focus onto the microwave passive devices. Now as you know that to study about the behavior of the microwave component, it is mandatory to have the idea about the S parameter. As we know that the ABCD parameter, X parameter, Y parameter and the Z parameters are there. But to get the idea about the high frequency waves, it is mandatory to learn about the S parameter. S parameter, in that the logical variable is the traveling wave. Traveling wave consists of the incident wave and the reflected wave. So a parameter set that relates to the traveling wave that are scattered or the reflected when the N port network is inserted into the transmission line. S parameter is important in the microwave designs because they are easier to measure. As we know that at the microwave frequency, it is difficult to short circuit as well as the open circuit the devices. So the measurement devices which we used at the lower frequency can't help here. So the two port network, okay, the two port parameters over here, you can see in the diagrams the two port waves, okay. The A1 is the incident wave, B1 is the reflected wave, okay, and the source voltage is the Vs, and at the load end we have connected the load resistance, okay, or the impedance, okay, load impedance that is connected. So this way the S parameter, that is important to have the idea about any two-port network. Suppose I can show you that this is nothing but the microwave devices, okay. It is the E-plane T, okay. So what I am considering this the E-plane T. This is my port number 1, it is my port number 2, this is my port number 3, okay. So what should I have? If I want to have the idea about the behavior of this particular component, I need to have the idea about the S parameters, okay. So that is why we need to study about the S parameter, okay. Now the next is YS parameter. S parameter, okay. So now in the voltage and the current are difficult to define and measure in the distributed circuit. The incident and the reflected wave, that are the natural description for the microwave structure. So conversion of from the S parameter to other parameter, that is the sets of the matter of the routine algebra. So here you can see that the device under test. So this is the device under test. If I am putting over here, it is my port number 1, port number 2. So when I am passing the input wave, okay, from the port number 1, what I need to use? I need to use, this is what? It's the match load. So if I am connecting my match load over here, okay, this match load over here, okay. So what I have by connecting the match load here. Now whatever I am applying from this port, it will come out from this port. There is nothing at this port. Similarly, if I am connecting my match load over here, what do I have? I have the match load at here. If I am applying the input from this port, I have output from this port, okay. So you can see over here. So over here it is what? So this is my device under test. If I want to find out the behavior of my this component, okay, I should have the idea about what? That's a S parameter. You can see over here. Okay, so the main thing about the S parameter, they are measured by sending the single frequency signal into a network or a black box for detecting the waves exits from the each port. Okay, power, voltage, current can be considered in the form of the traveling wave. Okay, and as I have shown, we are applying the input from the port number 1. Okay, we have the output from the all other ports. So now you can see in this diagram, that is the device under the test. Port 1, the incident wave, it is applying, and what you have the output at the port number 2. Okay, now what happened? That while you were transmitting the input signal from the port number 1, okay, what happened? That sometimes if I am considering it's my 2-port network, what I am doing? I am connecting it with the match load. Okay, so now what happened? My this port that is closed. So I am applying the input from this particular port 1. So what happened? That sometimes you are applying the input from the port number 1, you have the output at the port number 2. But part of the some wave which is reflected back at the port number 1. So now this kind of the consideration that we have to we want to know. And again, it is important to get the knowledge about the S parameter. Okay, so this is another diagram that you can see. It is my A1 is my incident wave, the B1 is my reflected wave from the port number 1. A2 is, suppose I am connecting the match load at the port 1. What I have? I am applying the input from the port number 2. So from the port number 2, my wave is A2, my reflected wave from the port number 2 is B2. Fine. So this way we can understand, we can give the idea about the any particular the component. So now to get the idea about all this kind of the 2-port network, we can describe the relations, linear relationship between the 2-port network by writing this equation. It is B1 is equal to, B1 is the reflected wave from the port number 1. So B1 is equal to what? So it is the S11A1 plus S12A2, and the B2, it is the reflected wave from the port number 2, B2 is equal to S21A1 plus S22A2. Fine. So this way you can describe the equation, okay, and we can get the idea of the behavior of any microwave component. So S11, S12, S21, S22, what are that? So that are the microwave parameters, S parameters, okay. So here in this diagram, you can see that A1 is the incident wave, B1 is the reflected wave from the port number 1, A2 is the incident wave from the port number 2, B2 is what? The reflected wave from the port number 2. Okay, so which parameter we want to find out? We want to find out S11. Mean what happened while you are applying the input from the port number 1, and at the port number 1, what could be the output? Okay, so I want to have the idea about my reflected wave, my incident wave. So the reflected wave divided by the incident wave, or you can say that the ratio of the reflected wave to the incident wave is nothing but it's our the S parameter. So now the one by one in the equation, okay, I can find it out, my S11. S11, okay, that is the B1 upon A1, okay, from the relationship B1 is equal to S11A1 plus S12A2. So now here, if it is my the 2-port network, fine, it is my 2-port network. What I can do, that if I want to find out the S11, it is mandatory to connect the match load at the other terminal. Okay, so now what happened? You are applying the input from this port. Okay, here the match load is there. So what happened? Your input will not propagate through this port and it is reflected back from this port. So while you are applying the input from the A1, making this A2 is equal to 0, and what could be the output at the B1? That is my reflected wave. Okay, so I can say that the S11 is equal to B1 upon A1 while A2 is 0. A2 is 0 means you are not putting that as A2 0 value, but while you are connecting it with the match load. Okay, what I have the match load, and by connecting with the any port, my value, okay, I am considering equal to 0 means my impedance, okay, that I am trying to match. Okay, so this way the S22 parameter you can also find out. So it is the B2 upon A2. Now B2 upon A2, this is what? Port number 1, port number 2. Fine. Now port number 1 is connected with what? With the match load. So now what happened? You are applying the input from here. Okay, input from here. It is connected with this match load. So this value that we are considering, it's a 0. So while you are applying the input from here, the wave which is traveling and which will come back to this particular port. Okay, so it is what? The S22. While A2 is connected with the match load, applying the incident wave from the port number 2. What is the output at the port number 2? So this way you can have the idea about the other parameter. Okay, so this is, I think, is clear to everyone about S11 and S22. The other parameter is S21. S21, okay, it is what? B2 upon A1, where A2 is equal to 0. Okay, so this is the A2 is 0 means port number 2 is connected with the match termination. While port number 2 is connected with the match termination, applying the input from the port number 1, that is the A1. What is the output? Okay, the reflected wave at the port number 2. So it is known as the forwarder transmission. Okay, and the insertion gain with the output port terminated in a match load. S12 is equal to B1 upon A2, while A1 is 0. Reverse transmission, it's an insertion gain with the input port terminated to a match load. So this way, these are the basics for finding out the behavior of any microwave component. Okay, so if the network is changed, the S parameter is changed. Okay, so not the S parameter remains same for all the component. So if the network is changed, S parameter is changed. If the transmission frequency is changed, network S parameter is changed. If the load impedance is changed, network parameter that changed. And if the source impedance changed, the S parameter that again changed. So this way you can have the idea about this. Properties of the S matrix is again important while you are deriving the S parameter for any particular component. So it is S is always the square matrix. Okay. What is about the square matrix? If I am having this component, how many ports are there? Port number 1, port number 2, port number 3. So its matrix for this component is 3 by 3 matrix. Suppose I am having this component, fine. It is my magic T. Okay. So magic T, okay, you can see this component, how many ports are there? Port number 1, port number 2, port number 3, port number 4. So this matrix, the matrix for this component is 4 by 4 matrix. Okay. So number of ports, okay, according to that, the matrix that we have. The S is an unitary matrix, means the S parameter of the one matrix, okay, and the complex conjugate of that, it gives you the identity matrix, okay. So this is what it is, again the property of this. And the phase shift property, that's again the another property, okay, for the S parameter, that if you are changing the any plane, okay, from the port 1 side, port 2 side, you have the phase shift. Now here for example the S parameters are given for the few components, okay. So you can see that first in the first example, transmission line is there, having the port number 1 and port number 2, fine. So the impedance, characteristics impedance is Z0. So by considering the equations, we can have the S parameter for that transmission line is this. This is the short, okay, is the matching short. This way we have, then for that the S parameter is this, and the amplifier, the S parameter value is this. So this way we can have the idea about the S parameter for any of the component. So now here we have the circulator. We have a circulator. S parameter is this. Isolator, S parameter is this. Okay. So now we are going to forward about the microwave hybrid circuit. What is the microwave hybrid circuit? So now that consists of the microwave devices. They are connecting with each other, okay, to achieve the desired transmission, okay. The interconnection of two or microwave devices, okay, that may be regarded as a microwave junction. So now you can see that this is my one component. What I want to do, that I want to connect with the other component. Fine, similarly the other component you are connecting. So you are establishing the microwave junction, okay. So these microwave junction, okay, how it used, okay. So now we have the waveguide T's, okay. So now we will learn about the waveguide T's. In that we will learn about E-plane T, H-plane T, magic T, hybrid ring T, otherwise other name is the rat race circuit. Okay, so now we will move forward to learn about the waveguide T as well as the other components, directional coupler, power divider, circulator, isolator, okay, waveguide twist, okay, waveguide band. So these all are the microwave passive component. Now we will learn about the T, okay, H-plane T, E-plane T, then the magic T, hybrid ring, corners, okay, then after the various bands, okay, the twist as I said, okay. So here I will show you, this is my H-plane T, okay, this is my H-plane T, fine. Now I will show you, this is my E-plane T, okay, this is H-plane T, okay, and it is the E-plane T, fine. And what is it? This is the magic T, which is the combination of the E-plane T and the H-plane T, okay. So now we will learn in detail about the E-plane T. So now here you can see that this is what it is the E-plane T, okay. Now you can consider this diagram, okay, over here, okay. So it is my E-plane T, okay. So you can see that this is what it is, my port number 1, then it is the port number 2 and port number 3, okay. Now in this arm, okay, for the port number this, okay, it is known as the collinear arm, and this arm which is considered to be as a side arm, okay. So collinear arm and the side arm. It is E-plane T. It is also known as the series T, okay. A waveguide T in which the axis of the side arm. Okay, you can see over here that wherever the E arm is written, okay, this is known as the side arm and it is my collinear arm. So waveguide in which the axis of the side arm is parallel to the E field of the main guide. Okay, now here another way I could draw the diagram representation of the E plate is given. Port number 1, port number 2 and port number 3. Okay, so now we have to have the idea about, so if the collinear arm are symmetric about the side arm, there are different transmission characteristics. One is the input arm, another one is the input side arm. Now here you can have the idea about it. Port number 1, port number 2, port number 3. Now if you are applying the input from the port number 1, okay, what happened? That port number 1 and port number 2 are 180 degree phase shift is there. So if you are applying the input from the port number 1, the output available at the port number 2, it is 180 degree phase shift. Okay, and at the port number 3, okay, we can have the output of both. Fine. Again, in the second diagram, if you are applying the port number input, okay, from the port number 3, okay, what we have? We have the output, okay, at the port number 1 and the port number 2, but they are 180 degree phase shift of each other. Okay, so now here I will show you that while you are applying the input from the port number 1. Okay, port number 1. Fine. So what you have? You have the output at the port number 2 and port number 3. Fine. Now at the port number 1, while you are applying the input, at the port number 2 it is 180 degree phase shift. Over here we are getting the output, that is the summation of the port number 1 and the port number 2. Okay, so this way we can have the idea about the E-plane T. Now matrix of E-plane T. Fine, as I said that okay, there are the 3 ports. So how many matrix, n by n matrix? 3 by 3. So element is S11, S12, S13, S21, S22, S23, S31, S32, S33. Now I know the behavior of my circuit. I want to write about the my scattering coefficients value. Okay, and what I say that okay, if I am the S13 and S23 are the out of phase by the 180 degree with the input port at port number 3. The meaning of the S13 mean what? You are applying the input at the port number 3. What is the output? Okay, at the port number 1. If you are applying the input at the port number 3, what is the output at the port number 2? So that is my S13 and S23. As I said that I am applying the input from the port number 3. What I have the S13 and S23, so they are 180 degree phase shift. Okay, so the value for that component is S23 is equal to minus S13. Okay, now if the port is perfectly matched to the junction, meaning if my port 3 that is perfectly connected with the match load and I am applying the input from the port number 3, okay, so there is no output at the port number 3. Okay, so what you will say that okay, my diagonal elements, okay, that is what? So that's 0. So S33 is equal to 0. Okay. Now we know about the symmetry property of the S matrix. Okay, that is Sij is equal to Sji. So here in the equation 4 it is mentioned S12 is equal to S21, S23 is equal to S32, S13 is equal to S31. So now in the equation 5 we are putting all the values in the equation. It is the S11, S12, S13. Now what is the S21? geometry property. S21 is equal to S12. So here I have written instead of the S21 it is the S12. S22 S23 is what? So according to this equation 2, S23 is minus S13. So we are putting that value in the equation minus S13. S31 is S13. Okay, S32 is equal to S13 minus S13. And what is the S33? It is 0. Why 0? Because you are applying the input, okay, from the port number 3. Okay, as you know that, fine, that 180 degree phase shift of each other, okay. So what could be the output at the port number 3? It's nothing but it's 0. So here we are putting that value. It is equal to 0. So now, according to the unitary property, you can also see over here, what is it? S into complex conjugate of that matrix. It is equal to the identity matrix. Okay. So now we are solving this matrix. Okay. So now how can you solve? It is my R1C1 with my row number 1 and the column number 1, equating it with the first element of this unitary matrix. So what do I have? I have R1 means S11. Okay, C1, it's a complex conjugate of S11. So S11 into the complex conjugate of S11, it's a modulus of the S11 square. Okay, similarly S12, S12 star. Okay, so S12 into S12 star. If you are comparing that with the other element, it's 0. So you can see that only wherever the diagonal elements that are the one, for that we have all the equations. Okay, so by solving this, okay, we can have all these equations. And we are putting this all value inside the equations. Okay, so by putting that value inside the equations, we can have the Eplate P value. Okay, so here by equating the value S11 is equal to S12. Okay, from the equation 8 we can write 2S13 square. So S13 is equal to 1 upon square root of 2. Okay, so now similarly the S11 is equal to 1/2 by solving the equations. So we have all the values. By putting the values inside the equations, we can have the Eplate P as matrix is this. Okay, so when you are applying the input from the port number 1, the output available at the port number 1 is 1/2. Okay, so half of the power that you are getting. Okay, so this way we are able to find out the relationship, okay, for the Eplate P, and you can have the idea about the behavior of the Eplate P. So thank you very much everyone.